Hi, this is Will.
And this is Sri.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. So, Sri, how's it going?
Pretty good. How you been?
Doing all right. What are you drinking?
I'm drinking the last can of White Claw Ruby Grapefruit.
Disgusting. Disgusting. Is it the same can or is it the same pack?
No, of course it's not the same can. It's just another instance of the same flavor.
Okay.
And somebody left it at my party, and I'm stuck with it.
Oh, okay. Well, that's what you get for throwing parties. I am drinking Wild Wonder lemon ginger sparkling drink and
Nice.
a kimono mikan. I have no idea what this fruit is actually, so we'll see. It looks citrusy.
Very obscure, very cool.
Yeah, very hipster. So, what are we talking about this week? We are talking about the React Reconciler. Have you heard about the React Reconciler before?
I haven't. It sounds fancy though.
What about React? Have you heard about React?
Yeah, so I've definitely heard about React.
Right. And so just to kind of go over it, all our shows we'll talk about what it is, what does a React reconciler let us do that's new, and what are some of the second and third order effects if this ends up being something that a lot of people use, and finally, like how can we get there? It's our optimistic take on these new things. So the React Reconciler is one part of the React framework, and React is a framework for building web front ends. And a lot of the web apps that you see are single page apps where the entire app is loaded on first load, and then every click or user interaction thereafter is handled on the browser client side rather than making entire round trips to the server to get a new page, which is how web apps used to work. And React allows programmers to simplify the front end programming with one-way data flows and the ability to declaratively say like what the next state in the view will be without worrying what the previous state is. Because before React, it was hard to maintain front-end web apps because they were either like two-way data flow binding, like two-way binding for the data, or you had to know what the previous state was and then what steps you need to take to get to the next state.
So just so I can summarize, I remember that like really early days, everybody was using jQuery, where jQuery is a set of tools to manipulate the DOM. You're directly editing the document that the browser is rendering. Mm-hmm. And then I think a second wave of tools I remember seeing are things like Backbone and Knockout and things like that, where they separate this data model from the DOM, but you're still doing a lot of the state management and data management, and it provides some utility classes such that when some state is updated in your app, you can then make the corresponding updates to the DOM.
That's right.
And then I think that React came in and kind of blew everything out of the water by saying, don't worry about the DOM, only worry about your application state, and we're going to take care of making those updates for you.
It was a big boon for front-end web application programmers because of this framework that lets you only declare the next state and what you wanted the view to be based on that. And React itself figured out how to get from the previous view state to the next view state. And in order to support that, React has what they call the reconciliation algorithm, in which they figured out the diff between the next state and the previous state. So as React has evolved, they've pulled apart this reconciliation algorithm, this core algorithm, away from the renderer so that you could write renders for any number of render targets and they would all use the same core reconciliation algorithm. And so that's how you can get React Native so that you can write React for mobile phones and React for the DOM, but still have the core reconciliation algorithm to be shared amongst all these different kinds of Reacts with different render targets.
Got it. So basically, the insight of this reconciler is that it doesn't matter whether you're running in a browser or you're running under some other UI framework, or maybe even no UI framework at all. That's you're right. Making mutations somewhere else in some other system, maybe a file system or something. So it doesn't matter kind of what your host environment is. The underlying service that React is providing is that you can tell React, this is my next state, and it will figure out the set of mutations that it needs to do to the DOM or to the phone front end or whatever to take care of reconciling that update with the UI state.
Well said, well said. Maybe you should have been doing the introduction for this part, but yes, that's a good summary.
Cool. All right. So that sounds pretty cool. So why is this exciting?
I think that's pretty exciting because the API for React, especially the React hooks, I found it to be very useful in writing more maintainable software. Because before React, the UI is usually where you try to tie the user's actions to some sort of view. And if you tied it directly, you would have problems in maintaining it. If you completely disassociate it with like an observer pattern, then it can be really hard to reason about. When one thing changes, it changes some other part of the page, which then might trigger something else, and you get this cycle of updates. Whereas with React, you are guaranteed the one-way data flow so that it's easier to reason about, and you only worry about the next state. So we can take this idea and transport it to other platforms to build front-end apps with. And I think there's a lot of different places in which we can use the core reconciliation algorithm, but then have different render targets for it.
Interesting. I think side effects are kind of well known to be the one of the hardest problems in computer science. A big source of bugs. You can have inconsistencies if you don't, update something when something should get updated, or you don't like invalidate or redraw something, and you get kind of weird, basically invalid states where the what's presented on the screen doesn't reflect the internal app logic, and you might get crashes, you might get bugs, you might get weird effects. So basically, what's cool about the reconciler is that you don't have to really worry about all of that as long as you're working within the paradigm that React presents to you. You have to kind of write things the way that React tells you to write them. And if you do, then you can sort of benefit from all the things that it's doing behind the scenes.
Do you find the way that React constrains you to be too constraining? Like, do you want to do things outside of what it lets you do?
I think that I don't write a lot of single page applications, so I don't really know the day-to-day struggles of using React. What I have noticed is that the community is always pushing the edge of what the framework sort of provides. So initially when React came out, it was pretty bare bones and its value prop was very simple. And then people kind of had to figure out how to represent state that lived outside of the components themselves.
Right.
And so there was like Redux and all that kind of stuff. And I think the community has sort of converged on the right way to do this, or several accepted strategies to do this. I think it's getting to the point now with hooks, at least what I've seen, where it's a pretty cohesive story, right? You can write these stateless components in side effect free functions. And this hooks idea allows you to pull in interfaces to the external world. So, either stateful interfaces or side effect-ish interfaces. And so maybe now it's not that constraining. I think the story is pretty clear on how to do things, the common things at least.
Yeah, I found the hooks API to be surprisingly good. And I was thinking that, okay, well, Redux feels wordy, but I didn't think that there was another way to do it, kind of another way to put it all together, because the Redux didn't quite address side effects. And in Elm, they have an effects system because it's a pure functional language. All the side effects are actually executed by the runtime itself, where you can only issue commands for these side effects. And I didn't think that you'd be able to do that in React, but effectively that's what hooks give you. It's a way to declare what it is that you want to do, and then the effect itself is written inside of the hook itself, whereas the use effect or use state or use whatever is the command to do the side effect.
Yeah, it's interesting. Like maybe this is an aside, and maybe it's a preview of our next episode, but I think that React is kind of pulling in a lot of these functional ideas. And I also wonder whether React dabbling in like pure functional languages like Reason, I think is at least affiliated with the React team. So I wonder whether that kind of thinking allowed them to come up with these ideas like hooks and port them back into the JavaScript runtime.
It is something that I have observed myself working on front-end web apps, that a lot of ideas from pure functional programming have sneakily made their way into front-end programming.
Yeah, for sure. So back to the React Reconciler, I'm curious, you mentioned there are different render targets that you can use and plug in and benefit from the same sort of reconciliation algorithm. So what are some examples of some types of render targets that you could use instead of just the DOM, which we're already all familiar with?
So one of the first ones that demonstrated this was possible was a blog post by this guy named Steve Witten at acco.net, acko.net. And if you've ever visited his webpage, you probably wouldn't forget it because it has an amazing 3D header with pipes and stuff. But in it, he was talking about how React had this reconciler, and he could take that same concept and apply it to constructing 3D scenes. Because if you've used WebGL or anything like it, you know that working with it is very imperative. You set this thing up this way, then you do these things, and then whatever state that you have, then you have to figure out what to do next to get from your previous state to your next state. With his demo, he was able to construct something like React for 3D scenes. And there is a version of a render for 3.js, which is a JavaScript library for 3D scenes that you can use as a render target, but still use the core reconciliation algorithm.
Cool. So then in theory, it means that you can represent 3D scenes as, well, what will it look like? So am I outputting like a JSX like tree that then is somehow represents as 3D scene?
Yeah. So for Steve himself, he built his own version of React, so he doesn't have JSX in there. But effectively, that's what it is, where he's able to construct the elements of a 3D scene. Like, this is a cube, this is where the camera is in a nested form, whether that's JSX or not, to declare that this is the scene that's being constructed.
Got it. Okay. That actually kind of reminds me of like A-Frame, I think, is trying to do the same thing, right? Like they have a DOM model for 3D scenes.
Which right. And A-Frame is like it's basically like a similar thing, but for VR, right?
Yeah, and maybe generally for WebGL. I think it's not related to React in any way. It's an entirely separate framework, but it sounds like you can use the React Reconciler, and maybe it demonstrates the power of this React Reconciler that you can plug in. If you plug in the right renderer, you basically get the benefits of what the A-Frame is doing, but in the React world.
Yeah, and I think that's pretty interesting because there's plenty of applications outside of web applications that could probably benefit from the hooks-like or React API to declaratively say what your views are based on what your data is. Like earlier, you were talking about examples. We can swing back to 3D if there's more to say about it. But one of the other interesting things are terminal programs like the command line interface. How do you pronounce that? CLI? CLI?
Yeah.
The terminal programs, and a lot of times like the I don't know if they originally had frameworks at all, but like it all seemed really antiquated to me. I haven't really built a really big full feature one, but as a web programmer, it'd be great if I can also extend the reach of the platforms I can touch and deploy to if it also includes command lines, right?
Yeah, and I think I haven't written any fancy command line applications either, but I'm familiar with some of the libraries. Like a common one that people use is curses or end curses or things like that. And these are all, like, as far as I understand, APIs that are not declarative, they're imperative. So you say, this line or this column or this group of pixels somehow turn it this color or set its text to this. And so you can basically plug that into this reconciler, and then you might be able to, rather than do all of that, just think of the terminal as a declarative thing where you say, okay, over here I have a box, and over here I have a button, and blah 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 blah.
Right. Yeah, and so that is pretty exciting. Although now I'm like, I don't know what I would build now that I can build terminal programs. Like I don't have anything like in my back pocket or something like that. But it definitely expands the possibility, because like for a while I stuck to making web apps because I didn't really care to learn Objective-C, I guess. But now that Swift is out, like that's more appealing. But definitely like having something like React Native makes it easier to make the transition, definitely.
Yeah.
And then I guess the final thing that I was thinking about was maybe something for, maybe this is a bit of a stretch, but for cluster configuration, because the idea of only having to declare the next state without worrying about the previous state reminded me of Kubernetes, because that's effectively what it does with the YAML manifest files, because those YAML files are effectively a declaration of what you want the state of a particular part of the cluster to be like, and Kubernetes will figure out how to get it to that state, right?
Yeah, right.
And so that I'm not sure exactly like how that would look, whether that like it would be way too verbose or kind of a wrong fit, but conceptually it's there. But like I said, it could be a little bit of a stretch. So that's what I was thinking.
Yeah. Yeah, I think that makes sense. I mean, in theory, you could map any kind of stateful system to this React reconciler. So yeah, maybe it's the state of your servers. Maybe it could even be the state of your network. So software-defined networking is like a big deal nowadays. So how can you configure your switches and your routers and your, BGP like thing to
for those people
laughing.
Who go for it. Yeah, in the
we're
future.
Laughing because like at the time of this recording, the Facebook had shut down for, I don't know, like the better part of a whole day a few days ago due to a BGP mishap.
Right. And so who knows if a React reconciliation would actually like fix that problem. But configuration problems are usually, yeah, they're already declarative. And so it's a matter of semantics to figure out like whether it's actually right or not. So yeah.
So maybe it wouldn't have saved them. But I think that, software-defined networking is a big deal these days. People want to push as much of this kind of configuration away from, hardware and moving things around and wires and switches and racks to being able to declare that in firmware or in software. And so maybe that's another use case. I'm not too sure about that domain myself, but who knows?
The other thing I was thinking about was rendering PDF files. I've had to do a little bit of that before, just like working on equity, because like normally in the old days when you get stock, you actually got a piece of paper that was really decorative and said that so and so is the owner of this many shares. And nowadays, most equity is digital, but some investors still like to get a printout of that thing. So we generated PDFs. And to my surprise, the API for PDFs is it feels very 1990s, in which everything's absolutely positioned. There's like no layout engine or anything like that. And you just kind of blast things onto the paper. And for something like that, a declarative API on top of it, especially when you need to move things out around dynamically, I think would be really helpful.
Yeah, I think so. I think that makes sense. Yeah, I had to render PDFs once, like generate PDFs once for something. And it's like, yeah, you're right. It's very 90s type API. Its worldview is very focused on printing the real physical documents. And so it's very different from the kind of way we think about rendering now. And so, yeah, I think if you had a renderer that just allows you to think about the page as just like any other kind of web page, and it deals with all the weird PDF commands, that'd be cool. Yeah.
Right. And so were there other applications that you were thinking about that kind of got you excited?
Yeah, I mean, I think that the UI aspect is interesting, and we can enumerate all the different UIs there are. Obviously, CLI, PDFs,
Yeah.
different types of even like hardware screens. Like you can imagine you could have a React renderer for like some like dot matrix like display thing, right? And the way that it's mutated is over some like USB or serial or
Dot
something
makes
like
for
that.
printers, right?
Yeah, dot matrix printer. Yeah. So or all kinds of other things like that. But I am really, really interested in thinking beyond the UI, because at the end of the day, the problem that it sounds like the React Reconciler is solving is that you live in an imperative world. And for the most part, even most things in the real world are imperative, right? You take an action and you do that, and then if you want to undo that action, you have to take another action and you do that thing. Right. And so if you live in this side effecty world, then the promise of the React Reconciler is that if you have the right plugin, you can interface with this environment in a declarative way. And so if you step out of this UI way of thinking, there's all kinds of computation which this could make sense for. A big thing that is interesting to me is how could this be used in a serverless environment? Because in this sort of Jamstack serverless-y way,
our favorite stack, right? Jamstack is our favorite stack.
except for local for software, which is supposed to be our first favorite one.
We can call that peanut butter stack. So
yes. So if you have these serverless functions, these Lambda functions or whatever, then how do you encode the state of your application? Because right now, I think the state of the art is kind of limited in that all of these Lambda functions are all operating in isolation, and maybe they make updates to some key value store, or maybe they kick off some like delayed job or something like that. But it's kind of incoherent. Like it sounds like it's begging for a framework that you can like actually tie together what's happening across all of these like Lambda functions and key value stores and things in this like declarative way, or at least be able to describe the side effects in a way that like the hooks API makes it very clear what actions you're taking or what effects you're mutating.
So you're saying something like, because the Lambda functions, despite the name, are not pure, right? They can yes. execute side effects. And so I've seen people come up with architectures of a backend only using Lambda function, and it just looks like a complete mess, right?
No, it's the future. This is the future. Embrace.
I know. I mean, like, I'd rather go, like, in all seriousness, I would rather just go back to doing monolithics rather than whatever like Lambda microservice sort of thing is going on. It can be overly complicated. And so if I'm hearing you correctly, you're saying, okay, like instead of doing all these things individually and separately, let's use something like a React hooks framework and the reconciler to orchestrate all these little Lambda functions so that it doesn't matter when or like what comes up or when it comes up, but all I have to do is declare what I want happen, and the system will figure out like what Lambda functions to bring up or down or execute, right?
Yeah, exactly. And it's a very common workflow. You can imagine that you have a Lambda function which is, serving as an API endpoint or as a webhook API, and it receives some data, it runs, and it kicks off a bunch of downstream tasks. So in response to its request, it downloads something from somewhere, downloads an image, it like resizes it, it puts it in S3, and then it kicks off a job, like a delayed job that does something with this image, right? And so basically, you're doing all these side effect-ish things to your, data stores, basically, right? Whether that's S3 or whether that's a database or whatever it is. And at some point, that's fine. Like the use case that I just described, you could just write that imperatively,
right?
But because that's a single function. But like, imagine you actually had to write a whole like backend like service, like not just like one API handler that like is all orchestrating and working in unison. You might want to have some framework that coordinates all these. And so maybe in response to one job running or one Lambda function running, it wants to call some other Lambda function, which has its own set of things that it does. And so it could be useful to say, rather than just doing whatever you want in a Lambda function, you use this hooks-like framework and you use this reconciler type thing, and it handles the calling of all these things and the writing of all these things. And so, it's a little cleaner, I think.
Yeah. That then it leads to something that I've been experimenting with lately. I built an ETL pipeline using a React Hooks API inspired by the Steve Witten's blog post on a headless React. And the inspiration for this was that in a lot of the previous apps that I had to do before, we had background jobs that needed to be run, but they weren't necessarily independent.
Yeah. ETL is an interesting one because,
well, it really reminded me of like basically like a chain of Lambda functions that you were mentioning earlier, right?
Yeah, definitely. So, and it makes a lot of sense. I've written ETL pipelines before, I think, Airflow came out.
But how much did you love that?
I hated it. It was horrible and very, very brittle. And the problem was, I mean, basically the same problem that you have with, inconsistent or incoherent UI state, where basically like one job could run and maybe it would fail, or maybe it will have written part of its output, but not a full output. And then you had to have its dependencies check, like whether it had really run or whether it needs to rerun. And so you had to have a lot of this custom logic to coordinate all this dependencies between things. And you'd have to like write like files that would be like, oh, this job was successfully completed and things like that. So you would know, oh yeah, now the world is in a coherent state after this thing ran. And so now it's safe for me to do my work. And so,
or maybe like sometimes it like overruns because like you've written it at the time, it was like not a lot of data, but as the data set grew, like at the time you've written it, you didn't think it would take like 12 hours to process. And now because like however you set it up, maybe it's a cron job, like the previous thing didn't finish by the time you're running your thing. It's just this whole, anyways.
And so you have to have something that checks like, oh, is the thing still running from before? And so you don't clobber like that data. I think that projects like Airflow have come out, which do take this DAG model, and they simplify things in a similar fashion to what we're describing, and that you kind of declaratively say, these are the dependencies of my jobs, and it'll handle the checking of success or fail or rerun something or run the appropriate dependencies. But I think that they're still very much in a batch world, where you have these jobs, There are big jobs that run, they take a few hours or they take a few minutes or whatever it is. And they're run periodically.
Mm-hmm.
There are other projects that are much more real time-ish.
Yeah,
where,
like streaming and whatnot, right?
Yeah, exactly. So if you have the streaming data but you similarly have this chain of dependencies, there are other projects that are trying to handle this type of workflow. I know, like there's Apache Storm and things like that. But it seems to me like this React reconciler could also serve as a model for this type of data processing.
I think so as well. That's my guess. And so I guess that's why we talk about these things, because it opens up a possibility for like what you can build with these things. And I think the React reconciler, it's been around for a couple of years now, but I don't see a lot of people talking about it. But that said, there's definitely people writing all sorts of renders for it, but the targets have mostly been for UI or something that is visual that you can see. I haven't seen a lot of projects that help you declaratively update, let's say, the state of a network or state of a cluster or state of your ETL pipeline. So backend like things.
I mean, I would be really surprised if somebody like literally took, the npm package React reconciler and then decided that that's going to serve as the core of their distributed systems scheduler. Like, I think
when you say surprise, you're like, that's a stupid thing to do, or like
I would be very doubtful of how much it would survive beyond being a proof of concept.
Because
I mean, I think just like the nature of one problem space is sufficiently different from the nature of another that like, even though maybe conceptually you could design a scheduler the same way between the two, at some point you're just going to want to do things and just slightly differently or design things slightly differently, that like it doesn't make sense for React Reconciler itself in its current manifestation to be the one true reconciler of all of the world. But it is, I think, exciting for me as just looking at it conceptually, right? Whether it is literally React Reconciler npm package, if you just take that architecture apply it broadly.
That concept and that pattern, right? Because like we're seeing that this is a pattern that is it's a combination of a couple of things, but that pattern and concept that we've been talking about and outlining, like that seems like something that is working really well for front end. And like at its core, it's talking about and addressing one of the hard things about computer science and programming, which is maintaining state, right? And so the quote about how there's only two things hard in computer science: cache invalidation and naming things. And so cache invalidation is a state problem, right? And so maintaining state, because the world is stateful, but in order to get that under wraps for our brains to kind of comprehend systems that we build that help maintain state, it's been one of the core fundamental problems when architecting systems, I believe. Have you read a paper called Out of the Tar Pit?
I have, yeah. It's been a while, but yeah, I've definitely read that.
Yeah, so just as a quick summary of the paper, they basically are saying state is a hard thing to wrestle with in computer programming, and we should do our best to compartmentalize it using tools from various disciplines, from like declarative programming and functional programming and stuff like that, to contain state as much as possible.
Yeah, I think it makes a lot of sense to just apply this general principle wherever you see this problem. And it's the funny thing about computer science is that unlike a real science, it's a lot of like developing a shared understanding and a shared vocabulary together to advance the state of the art. So what I mean by this is that if you think about something like querying data, before SQL, there were all kinds of weird ways that you could query databases.
They used to do it imperatively. Like if you look up like hierarchical databases came before relational databases. And when I looked into it, it actually really reminded me of XML when people tried to make XML queryable. And so effectively, any query that you had was dependent on how the data was structured. So you would have to declare a path, state a path through your data.
Right.
And that's what hierarchical databases were. And so like it's kind of like we moved away from that when we discovered relational back in the 60s and 70s. And then when XML came around, they're like, oh, let's just do this hierarchical thing again. Which is funny that there's this loop. But anyways, that was something that reminded me. Oh
yeah, no, that's like a good historical context. Like right now, if you ask people what's the state of the art of querying data in a data store, the data store is structured in this relational way, and then the query language is declarative. It can be SQL, or people write other types of query languages, but ultimately it's all kind of based on this fundamental concept of like relational algebra and whatnot. And it took a while for the sort of our shared myth and our shared understanding of computer science to converge on that being the default way that you structure data. And I think that in terms of UI, we've had all these generations that I outlined earlier where we were kind of fumbling around collectively as an industry of like, how do you structure these APIs? And people iterated and got closer and closer and closer. And I think that React is sort of the pinnacle, right? Like now, if you're starting a new UI framework that's not React, people will ask you, well, why don't you do something like React? If you decide to do something different, people will look at you funny and ask you to justify yourself.
Yeah, I mean, on one hand, yes, I would agree that it seems like we've really kind of come up with something where the solution fits the problem like a glove. But that said, I am reserving the possibility for something else to come along, because like when I was using the Elm architecture that I mentioned before, I couldn't imagine like hooks being that much better, but it turns out that I really liked it for a variety of reasons. And so, I would say that after you having used previous front end frameworks from jQuery onwards and finally landing on React, it does feel like this seems like a really good fit for the problem at hand, right?
Yeah, for sure.
And so we have the feeling that it could migrate to different stacks, different platforms, different parts of the ecosystem. One of the things that I wonder about, though, is in gaming, because in the previous episode about local for software, you mentioned that, like a lot of other industries get inspired by the architectural practices of gaming. In some ways, they're really far ahead of like people writing web apps or business apps and whatnot. And one thing that games used to do was they would have two buffers because the screen wasn't fast enough to update. So what they would do is they would display one buffer on screen, and then on that same frame, they would be writing to the second buffer. And then when the time was up for the frame, they would just switch the pointer to the buffer. And so that's how they would achieve the 30 or 60 frames per second that they need. And so effectively, they just blow away the previous state of the screen at any one time. And so in that way, it's very much like React, in which they don't care about what was on the screen before. They just want to write the next state. They just blow it onto the screen. But that said, I don't see them using anything like a React reconciler for things that are higher level, like the scene construction and stuff like that. They're still very much, and I think there's a certain adherence to performance for game programmers that I don't know that they would tolerate the overhead a declarative API might introduce into their game.
Yeah. I mean, it makes sense in terms of rendering because they are really pushing the limits of, every technology platform that they're on. And so, you at some point, the small performance hit actually matters, right? In terms of what you're actually able to output onto the screen.
Yeah.
But like you mentioned, I think the higher level constructs do make sense. So there's a lot more to gaming than just rendering. So you have screen construction, but not only that, within screen construction, you have these objects, and a common architectural pattern that people use is kind of entity component systems. So you say this is an object, and this object has the property of being whatever, destroyable or movable or whatnot, right? And so all of those are not really in the critical path, I think, of rendering. And so it makes sense that you could declare your world in this declarative way. Because I was watching sorry, go ahead.
Oh yeah. No, I was just agreeing because most of the effort, I think, in optimization is in rendering, because that eats up most of your frame. And so like people that try to optimize on their entity component systems usually are wasting their time because that's not where the computer's spending most of their time. And so if you can make that a lot easier, you might be willing to eat some overhead for like better maintainability for that sort of stuff, like that, or scene construction or something like that.
Yeah, and I think there are a lot of bugs that actually manifest from doing this. Like you if you play games, sometimes you like do think some weird sequence of events, and now like you can no longer like move past a door or something. And I'm sure that's due to some like corrupted state where they didn't like properly, update the door as being closable or movable through or whatever.
Yeah, actually, like there's like YouTube videos on like why doors in games are like such a pain in the ass to do. And one of the things that they pointed out was the easiest doors to do are like the Star Trek sliding type doors, because none of the objects, like the people or objects in the world, interact with those kinds of doors, right? And then the other kinds is where they the next easiest are the doors that swing both ways, kind of like in a saloon, right? Because like it's just a lot easier, and they let them swing through stuff. But some of the more recent games where the characters have to reach for the doorknob and like push through, and you can only swing them one way through, there's a lot of edge cases that they have to handle where, I mean, if maybe there's something on the other side, or like do you knock the other character over, so on and so forth. But yeah, like now that you mention it, like these weird states that you can get into for games could be constrained with something like a declarative API, in which the system itself has a set of rules to figure out how to get from the previous state to the next state. And so it's not up to the user to kind of figure that out. But then would it get rid of certain type of bugs like the cats dying in Dwarf Fortress?
I think I know what you're referring to, where
right.
You have this like weird chain of events that
right, because in Dwarf Fortress you have a lot of different rules as to how the world works, and they've found. Do you remember the story? I'll let you tell it if you remember it more.
No, I only remember that it was pretty hilarious when I read it, but I don't remember the specifics.
I think it was that when the programmer, the guy that was programming Dwarf Fortress, added like a new rule about how cats can lick their paws, he found that cats started dying in bars for some reason, and turns out that they were stepping around in the alcohol that the dwarves were spilling in the bar, and then they would soak it up with their paws, and then when they lick their paws they would get alcohol poisoning and die from so these sort of things. I think it's kind of the unintended consequences of a lot of different rules for any one rule system, I guess. So I don't know that React would be able to that's a configuration problem, right?
Yeah, well, I mean, one, I don't know if that is in particular a problem. Like, I'm amazed that like the world was modeled enough like at such detail that that emergent behavior could happen. But two, I think that there are two kinds of bugs that you can generally classify things into. One is where the system is in a like valid state. It's just not the state that you want it to be in. And I think, like, for example, if you're a game designer, all of those subcomponents of Dwarf Fortress were working properly, right? The alcohol poisoning subsystem was working great. The thing that models like the floor is covered in alcohol, it was working fine. Cats licking their paws subsystem also working fine. And so all of the states there were coherent, they were working, they were doing the thing that they were supposed to. If you wanted to call it a bug, then the bug is that the outcome was semantically invalid. It's just not what you want the gameplay to be like. And so there's that class of bugs. And then there's the other class of bugs where your system is in an invalid state, where the state of your variables and the state of the world and the state of your runtime doesn't represent any semantically coherent thing, right? So if you have your screen tearing, you have a door that's open, but you cannot walk through it. Yeah. These are things where the system is incoherent. And so I think React Reconciler handles the class of bugs that are in the second category.
Yeah.
It doesn't do anything for you if everything is working fine, but you just don't like the outcome.
The
thing.
That's true.
But I think like there's a like pithy phrase that I think a lot of functional programming enthusiasts like to use called like make invalid states unrepresentable. So it's this idea that like if there's some state of your data or the state of your variables or whatever that is invalid, it doesn't actually represent anything that is coherent, then you should use tools that make it impossible, or at least as hard as possible, to reach that state, that corrupted state.
Yeah, I think a short version of that is make impossible states impossible, so that you can't even represent it in the system.
Yeah, exactly. And so I think that React Reconciler, if you follow that model, takes you a lot of the way there, right? So you can't represent the DOM tree in some weird way where clicking some button is no longer bound to the, underlying thing that it represents. Like all of those kind of bugs that used to be possible, I think in like jQuery, like are no longer really possible. And I think that you could do
where you click a button and nothing happens, or if you click a button, it cycles through everything. And so like it's in a state where you just don't recognize the screen to be the interface to the app anymore, right?
Yeah, exactly. Or like, a big class of bugs was like in lists, where if you added a list item somewhere, then the DOM tree elements that were at some position in the list were still bound to where the list item conceptually what it used to be. So if you like deleted something at position like 10 in the UI, it would actually delete like some other position in the underlying array that it represented.
Whatever. I don't even want to have to think about that sort of stuff anymore.
So I think all of those kinds of problems are gone now, I think, for the most part. If you're disciplined, you follow all of these best principles. And I think that there are still a lot of those incoherent states in the rest of the world where, I don't know, maybe I don't really deal with like Kubernetes and DevOps and things enough to know, but I'm sure that there are like weird incoherent states that you can run into where like some server is spun up, but it's not associated with the right like load balancing group or something. And maybe something like React Reconciler will take care of that.
Right. I like the idea that it's the concept, it's this design pattern behind this like React and React Hooks API and the reconciler. If it turns out that this idea is more prevalent and kind of spreads throughout the programming world, like what sort of second and third order effects do you think will like emerge in the future? Because like to me, it seems like it's a pretty good and solid idea that can hold its own, and we can see that it has like possibilities in other platforms and other stacks. But like, given that it would be adopted more, what do you think the second or third order effects would be? And I guess one that you were saying is hopefully less state derived bugs, right? But are there others?
Yeah, I mean, one, I think that a lot of time is wasted in any time a new platform comes. People are just like reinventing the wheel about like, okay, how are we going to handle the UI? How are we going to handle state? How are we going to do this? And so maybe one second order effect is just it's the default. You have a default set of patterns for any new platform that comes up, and a lot less time is wasted in all tinkering around with these fundamental core things, and you can sort of think at a higher level of abstraction.
So you mean like LAPACK? It does remind me that the linear algebra package, which is LAPACK, it's written in Fortran, and a lot of for good reason. Fortran is very good language for numeric computation. Like that's what it was invented for. And so a lot of the libraries used further up the stack in like Python, in MATLAB, in R, like if you look under the hood, a lot of them are based on LAPACK. So they like compile the Fortran version and wrap around it. And so in that sense, that's what you're asking for, right? For something like a reconciler as the core for other things that then, can wrap around that.
Yeah, that would be really hilarious if like 20 years from now, every new programming language or platform links in JavaScript and Node, and people are like, what is this like a weird obscure language that like it's pulling in, the same way we ask about Yeah, maybe. I think that at the very least, the starting point of any new platform is going to be less about the kind of basics, the same way that now, we don't really about memory management and stuff like that. Yeah.
Obviously there are people that do, right? Embedded programmers and game programmers, especially, like those
Yeah.
people definitely still do. But for web developers and application developers, for the most part, we can kind of pretend that like that stuff is of no concern to us.
Yeah, exactly. Yeah. I think another one that's sort of a macro, like almost just economic benefit, is that a lot of what software developers do is basically handling state. Like at some point, you're just like, once the system is running and all the interesting parts are done, most of what the team that's maintaining whatever system is doing is making sure that, oh, if somebody wants to add a feature, okay, let's add the feature, but let's like make sure that that thing doesn't somehow corrupt all the other things that are going on. And so, I think millions or billions of dollars are just spent on programmer hours handling these impossible states and trying to make them impossible, not through any tooling, but just through the sheer brute force and ingenuity of human beings, like being careful.
Yeah, I've worked at places in which the rules for updating stuff is more than I can fit in my head. And honestly, like all we did was just fix bugs as they came up. Like we never had time to go figure out the root cause of like our state model or whatever. We just kind of fixed it as it came up. And so that was just kind of, I guess, understood to be part of the work. But like I did feel like I wish like we could take a step back and figure out like we're probably modeling this wrong somehow, right? So
yeah, definitely. Yeah, and I think like now with React, just pure UI React, one person, one developer shops are able to put things out on to Product Hunt that are of like a complexity that previously would have taken some whole front end team back in the day, like working in jQuery or whatever it was. And I think that maybe by reducing the complexity of bugs and state management and whatever this reconciling algorithm, maybe one developer shops are able to do a lot more complex backend systems too.
So then I do wonder if it would be analogous to people spending tens of thousands of man hours on SQL query engines and query planners, because like we all have the luxury of just writing SQL declaratively, whether we love it or hate it. But I know that so much time and research, even today, has been sunk into making those things fast. And still, we like sometimes it's just not fast enough. We'll just throw a cache in front of it. But databases nowadays are pretty impressive for what they do. Do you think that a similar amount of man hours will be sunk into reconcilers, whether they're React or not, to support this pattern?
Yeah, I mean, I thought you were going in a different direction with this, in that I think right now we are implicitly spending, tons and tons of man hours on writing reconcilers, whether we know it or not,
right,
that are like at the core of whatever system we're running. Like,
right.
And the promise of the database was like, oh, you don't need to care about just use MySQL or just use Postgres or
you
whatever.
don't need to care about how it's structured on disk, and you don't need to care about like retrieving that thing however it's on disk. You just write the declarative thing and save yourself.
Yeah, exactly. So maybe I thought you were going with like, we're kind of implicitly writing all our own reconcilers in every app that we create. So maybe having this like one reconciler pattern or a few reconciler libraries for every single programming language or platform, the main ones, will free a ton of people's time.
Yeah, I think so. I mean, one of the things that wrestle with is the complexity of software, and maintaining state is just one of those things that you have to get used to. And I do wonder if we could all be doing something else, maybe still related to programming, but sometimes when you're just wrestling with combinatorial state, that's when those sort of thoughts start to enter your mind. So definitely, I think if we embrace this particular pattern for the appropriate problems, then it would erase those entire class of problems. I guess hopefully in the same way that people used to wrestle with memory management, that we don't anymore. I do wonder if it made sense as a second and third order effect. Would it be useful to build an entire runtime with this pattern built into it, so that the hooks API and this declarative API is built into the runtime as a language level construct?
Yeah, that's interesting.
Because React, the reason why I bring that up is because React itself is effectively a runtime implemented in user land in the browser, because it has its own scheduler to break up the reconciliation work and everything. And so if that's the case, then could we kind of build a runtime with this React reconciliation algorithm built in? And what would the effects of that be? Like, why would you want to do that? Would they have benefits?
Yeah. One thing that's interesting is that because, like you said, the React reconciler is in user land, it's running on top of the main JavaScript runtime of the browser, or I suppose of like Node or whatever, if you're running like server-side rendering, right? Or something like that. But at its core, JavaScript runtimes are single-threaded, like evented systems, right? And so if you push this React runtime lower level, so if you didn't push the React runtime lower level, then you're stuck with whatever concurrency model and whatever primitives are exposed to you by the base runtime, right? Your language runtime.
Yeah.
I suppose that if you pushed this React model to the lower levels, then it could expose some other types of, lower level constructs, like maybe you could have some other kind of concurrency or parallelism model that's powered by React Reconciler or something. Like, could React Reconciler do something about threading? And a lot of class of bugs with threading is about sort of awaiting the threads.
I guess that would, this is us hand waving here, but like the whole task of getting from previous state to next state, are there parts of that could be parallelized? And so it would be up to the runtime to determine that, and all you have to do is declare the next state. Maybe this is very problem dependent, and I'm not sure that like a single reconciler would be able to figure that out. Maybe not. I'm not sure. But I guess it's interesting that you mentioned that, because the hooks API for React was inspired by algebraic effects, and algebraic effects is a relatively new construct, once again from the world of pure functional programming, in which you separate the use of a side effect from the handling of the side effect. And in this way, you're able to construct a control flow, even parallel control flows. It's not in any of the mainstream languages, but one of the interesting things is that in those languages, you can use algebraic effects to implement coroutines. try catch blocks and exception handling and other kind of control flow constructs that are normally language level features.
Yeah, I think that's really interesting. Like coroutines, yeah, other types of control flow things, other types of blocks that kick off side effects of some type. And that's almost like rather than the React Reconciler being pushed into the runtime is also related to maybe having its own syntax or its own like add-ons, language add-ons.
Mm-hmm.
That would be interesting as well.
Yeah, I was thinking that one of the interesting things about doing this is you get an effects system in the runtime. So now you have a way of handling side effects that, it's basically a way to separate the handling of state from when you tell something to handle the state, right? So you can contain state and so keep things a little bit more maintainable. Yeah, I mean, there's plenty of languages, like things that are kind of going this direction, although they may not have come through the reconciler, but like there are efforts to kind of go in this direction already.
Yeah, although I gotta say that for all the crap that people have given JavaScript through the years, it's the fact that you could build a runtime like this on top of what everybody calls a pretty shitty language is pretty amazing. I think it's a testament to the flexibility of what you can do just in user space. If you have a language that supports simple things like, closures.
Closures, first class functions, and
yeah. So, I mean, I think there are benefits. Definitely there are benefits, like we mentioned, of having the reconciler be more aware of the internals of, the concurrency patterns and maybe IO patterns and things like that. But I don't know, I like the idea that like JavaScript, the React Reconciler could have been written if 10 years ago, 15 years ago, if only we had known about it. Like it wasn't a hard technology problem. It was just all in our minds, right? If we had just envisioned it, if somebody had a time machine and went back to 2005 and said, hey guys, how about this reconciler pattern? We could have saved everybody so many years of grief.
Maybe. I mean, optimistically, yes. I mean, I would say it definitely would have saved me a couple of weeks, if not months, of my life. So I could have been playing video games or something else, right? So yeah, I guess there are definitely things that are still yet to be discovered that's still right under our noses. Yeah. So I think in this the idea of this reconciler, I think we've outlined like why it gets us so excited. But do you get the sense that a lot of people know about it yet, or is it still kind of like a hipster tech? Because apparently we only cover hipster tech on this show.
I think I haven't heard anybody mention the word reconciler in any of my conversations with people.
Oh, okay. Yeah, I don't see it much on HN or anything like that, which then I was really excited when I discovered it. But I don't know, like given how many renderers that there are in the awesome list, like definitely there's different enclaves of developers that know quite a bit about it already.
Yeah, I think it's something similar to when Node.js came out and this idea of asynchronous programming, which was possible all along in a ton of other languages like Java. It sort of took this sort of flagship project like Node to then bring that type of programming model to other languages and get people excited and rally around that.
So that's a call to arms to build the runtime with React built in. Is that what you're saying?
Yeah. Yeah. I think that if people like sort of decouple this pattern from just purely for UI to other types of problems, and I maybe people, I'd like to see it proved out, all these crazy ideas that we have, that maybe you can use it to declare your networking stack or your whatever servers. Like if people play around with this idea a little bit more, then I think that people from other parts of the world that are not focused on React will see the potential and start to rally around it and bring it to other platforms.
Yeah, maybe more, I don't know, strange loop talks, or like where I guess things despite technology moving fast, like tools and ideas for developers, and especially programming languages, are really slow. Like you would think technologists love and embrace change, but in fact, I think a lot of us don't like it that much, is the sense that I get.
Yeah.
To the extent,
have you read Sapiens? You must have.
Yeah, I think I have. I have. What about it?
So the concept of Sapiens is that there are stories that emerge in society, and as we tell ourselves those stories and start to believe in them, it enables us to do more and more things. And this is kind of this point that I'm trying to get at, with the fact that like the reconciler was all, in our minds the whole time.
I see. Yeah.
Like it's just this, there's like so much of this industry is just like storytelling, right? You had to convince people back in the day of the fact that like if statements were a good idea, and now you take if statements for granted in every single language that anybody knows.
Yeah. Not even if statements, but like programming languages in general, right?
Yeah,
people used to think that like having a compiler is a complete waste of computer time. Like there's no reason, or like I only need go-tos, right? So I mean, it's the same thing today, and I definitely hear you, because a lot of our best practices are not rooted in any sort of experimental science. Like a lot of it is people write a blog post and then other people pile on because like it's, I don't know, it gets traction for whatever reason, and so we're all just kind of fumbling in the dark based on our own experiences, as well as like what we've gotten away with before, right? So
yeah, definitely. So somebody
and the stories that we believe and that other people believe about, like whether like good coverage is a good thing, and so like we experience a little bit of it, we tell that's our story, and then we hear other people's stories, and so we can only approximate like whether it's actually effective or not, right?
Yeah, exactly. So maybe somebody somewhere will see the light of the benefit of React Reconciler, and they'll go back to their tribe and say, hey, like over there they have a really cool reconciler thing, like we should also use it, and maybe it'll spread.
So you don't feel like there's like this thing that is missing, whether it's like this proof of concept, or like, well, maybe like some sort of flagship thing, but like it's the idea has to filter out on its own and take its own sweet time to filter out to different industries?
Yeah, I think so. And like you mentioned, maybe just like a cool like strange loop talk or something, where somebody makes like a React Reconciler, like a renderer for like a loom or like a knitting like machine or something. Like Strange Loop really loves like fabrics,
like the knitting stuff.
Yeah, so like if you made a React renderer that somehow plugged into that, like that's sufficiently catchy and kind of breaks your model of like what React is.
I don't know. I wonder if it's like, if there's a new platform that was introduced and was a framework that caught on to the rising wave of new platform or hardware, and that thing happened to incorporate this model, I think that might be the thing that helps it take off.
Reconciler for serverless. I think it's a real thing. Somebody should make it, and you'll become famous.
We have so many startup ideas here. Of course, like disclaimer, like we don't know what we're talking about, so go ahead and try it out. Yeah. Okay. And we're like, if I don't know. Would we?
But
get
if it
advisors?
Succeeds, then you have to credit us.
Right, credit our. You don't want advisor shares.
Yeah. Okay. Yeah, I want advisor shares.
Yeah. So we'll see. But yeah, I think this is pretty promising. And so hopefully, like those of you out there, whether you got like other things that would be good targets, we'd love to hear them. Or if it inspires you to build your own weekend project, let us know in the comments. Would be down here, yeah, and whatnot.
The doobly-doo.
Doobly-doo. So I am all tapped out. My optimism has lifted off. What about yours?
I am in the stars.
Yeah, in the stars. So this is Will for Shri Thatibamala. This is Will Chung.
This is Shri.
And we hope to see you around next week on the Technium, where our optimism takes off. So if you love this podcast, smash that like button and subscribe and share. And we will see you next week.
See ya.
Take care. Bye.